Dear students, today we are discussing about important theorems from triangles. First one is basic proportionality theorem, that is BPT or Thales theorem. A famous mathematician Thales has given a conclusion for basic proportionality theorem, that is, if a line is drawn parallel to one side of a triangle to intersect other two sides at distinct points, then the other two sides are divided in the same ratio.
Now let's understanding the basic proportionality theorem. Consider triangle ABC and draw a line parallel to the side BC which cuts the sides AB and AC at 2 points D and E respectively. Point D divides the side AB into two parts AD and DB. Similarly, point E divides the side AC into two parts AE and EC. So, according basic proportionality theorem states that DE parallel to BC, then AD by DB equal to AE by EC. For deeper understanding of basic proportionality theorem, now we will look at interesting example based on it. David was standing below a pole built in his school. The length of his shadow and the length of the shadow of the pole we can see here. The lines connecting the ends of the two shadows at their maximum height were parallel to each other. If the height of David was known, then find the height of the pole. Can you find this? You may think that it is not possible to do without a ladder and a ruler. But solving such similar questions becomes easy with the help of basic proportionality theorem.
Can you test the converse of basic proportionality theorem? Will this also be true? Converse of basic proportionality theorem is if a line divides any two sides of a triangle in the same ratio, the line must be parallel to the third side.
Let's consider triangle ABC. If a line divides the sides AB and AC in the same ratio, that means AD by DB equal to AE by EC. According converse of basic proportionality theorem, the ratios are equal, then the line must be parallel to the third side. So DE parallel to BC.
Next is areas of similar triangles theorem. The ratio of area of two similar triangles is equal to the square of the ratio of their corresponding sides.
Consider two similar triangles ABC and PQR. According area of similar triangles theorem, area of triangle ABC by area of triangle PQR equal to AB by PQ all square or BC by QR all square or AC by PR all square. Let's see one example based on this. Given triangle ABC and triangle DEF are two similar triangles with the sides BC is equal to 3 cm, EF equal to 4 cm and area of triangle ABC 54 cm square. How to find area of DEF? So here we are using the concept areas of similar triangles. Let's solve this together. We know that the ratio of area of two similar triangles equal to the square of the ratio of their corresponding sides. So here area of triangle ABC by area of triangle DF equal to BC by EF all square. So substitute the values, cross multiply. So you can find area of triangle DF as 96 cm square. So in this such situation, we are using the concept area of similar triangles. Next is very important theorem, Pythagoras Theorem. What is Pythagoras Theorem? It is very simple. We often hear people asking if Max's theorem could be applied in the real world. So let us explore the theorem which can be used in many circumstances and learn how to solve it. Greek mathematician and philosopher Pythagoras, who is believed to be a pioneer of this theorem. Pythagoras only given the proof of this theorem. What does the Pythagoras theorem actually say? In a right triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Let us look at each of its terms with the help of an example. But before we start with our example, we need to learn few terms first which are essential to understand. Now visualize a right triangle ABC at angle B 90 degree. In this diagram, AB and BC are legs of this triangle and the side opposite to the right angle triangle, which is AC, called the hypotenuse and is the longest side of the triangle. An old man was trying to place a ladder on the window of a building above the ground. Anoop decided to help the old man. He placed the foot of a ladder at such a distance from the wall that the top of a ladder reached the window. If ladder 13 meter long in such a way that it reaches a window of a building 12 meter above the ground, can you find the distance of the foot of a ladder from the wall? Here, if you observe carefully, you will notice a right angle triangle. So with the help of Pythagoras theorem, easily we can solve it. In grade 10, we shall prove Pythagoras theorem using the concept of similarity of triangles. Pythagoras theorem is sometimes referred to as the Baudian theorem. What about the converse of the Pythagoras theorem? You have already verified in the earlier classes. This is also true, just opposite of Pythagoras theorem. Converse of Pythagoras theorem states that in a triangle, if the square of one side is equal to the sum of the squares of other two sides, then the angle opposite the first side is a right angle. It means that AC square equal to AB square plus BC square, then angle B equal to 90 degree. Thank you for watching my video.